Hello friends, welcome to another video of Zeta Axis, and today we will discuss about Atlantic Ocean currents. So here we can see permanent winds. These are the trade winds, and as we can see that these trade winds, they flow along the equator. They do not cross the equator, but when they reach the equator they will flow parallel to the equator. And it is this dragging force created by the trade winds which creates the equatorial currents. We can see that both in northern hemisphere as well as in southern hemisphere we have these equatorial currents. We can also note that south equatorial current is just adjacent to the equator, while the northern equatorial current is little northwards of the equator. The reason for this we will see in the later part of this video. Now there are two forces which create this equatorial current. The first is rotation of Earth and inertia, while the second is the trade winds at ITCZ. This we have already seen. So in this, that the trade winds at ITCZ, they flow almost parallel to this intertropical convergence zone. And therefore we see that the dragging force on the ocean water by these trade winds creates the equatorial current. Our Earth rotates from west to east, and because of this there is a movement in the water due to inertia. The water tries to hold on its position and therefore it is moved westwards. Just try to imagine a vessel having water and you are dragging the vessel in one direction. We will see that the water accumulates in a direction opposite to the motion. It is because of inertia. The water particles are trying to stay in its position. But because the vessel is moving, we see that more and more particles, they get accumulated over here. A very similar thing occurs in our oceans. If we see, these are the continental margins, and our Earth is rotating from west to east. It is rotating in this direction. And because of this force and the inertia of the water, we see that water moves in the westward direction and it accumulates on the eastern margin of the continents or western side of the oceans. So here we can see that because of the trade winds and because of rotation of Earth, water moves from this side towards the western margin of the oceans or eastern margin of the continents. And because of these two forces, we see that there is a equatorial currents. These are the properties of the equatorial currents. We can see that the north equatorial current is located between 10 degree to 20 degree, and it is caused by rotation, Earth's rotation and northeast trade winds, while the south equatorial current is located between 0 degree to 20 degree. So as we have seen, the south equatorial current is just adjacent to equator, while the north equatorial current is little north of the equator. This is again caused by Earth's rotation and southeast trade winds. The south equatorial currents at the Cape of San Rocco divides into two parts. The part which moves in the northern direction is called Guiana current, and the part which moves in the southern direction is called Brazilian current. So here we can see that this is Cape of San Rocco, and here the south equatorial current divides into two parts. One part goes in the southern direction and it is called Brazilian current, while the other part goes in the northern direction and it is called Guiana current. Now let's see how the counter-equatorial currents are formed. Earlier we had seen the formation of equatorial current, and now we will see the forces which cause this counter-equatorial current. So it is because of western intensification, gravity and lack of winds in the doldrums. So we have seen that the winds flow parallel to the intertropical zone, but they do not flow in the intertropical zone. This yellow region, there are very less winds in this region. Therefore, the dragging force of the winds which is present just above this region is not present in the intertropical convergence zone. Now earlier we have seen that because of western intensification, water accumulated here, and this was possible because wind force and rotation of Earth created a combined effect which overcome the pressure gradient created by gravity. But in the doldrums, what happens in the region between these two currents? We see that there is no trade winds, and therefore now the force is only of rotation of Earth, and this force is now less than the pressure gradient exerted by the gravity. Therefore gravity is now able to pull water from here towards the eastern side. And therefore, in the middle of these two equatorial currents, we see a counter-equatorial current. and it is mainly because in the ITC doldrums there are no winds. So there is only the force created by rotation of Earth, and it is less than the pressure gradient created by the gravity. And therefore we see that water from both this South Equatorial Current, from Guiana Current, and from North Equatorial Current, it moves backwards. And this is our equatorial counter current. So water from both this North Equatorial Current and South Equatorial Current comes back. This water is less in the amount of water which has moved from here, and even we can see that the thickness of equatorial counter current is very less compared to the South Equatorial or North Equatorial Current. So this is basically a weak current. Now we have earlier seen that the equatorial counter current and the North Equatorial Current is little north of the equator. And the reason is that the ITCZ is little north of the equator during all of the months. Here we can see in July the ITCZ is over here, while in January we see that ITCZ is located above equator. So you can clearly see that the ITCZ never crosses the equator in the Atlantic Ocean, and therefore the net effect is that the ITCZ will be somewhere here. And therefore we see the counter equatorial current in this region and North Equatorial Current in this region just above the ITCZ. So here is the summary of Atlantic equatorial counter current. It is caused by western intensification due to north and south equatorial currents. So because the north and south equatorial currents drag the water towards the western side of the ocean or eastern margin of the continent, we see accumulation of water over there, and this is called western intensification. Now the equatorial counter current is located above the equator in Atlantic as well as in Pacific. Because of the location of ITCZ remains in northern hemisphere throughout the year, and these equatorial counter currents are narrower compared to equatorial currents. We have earlier seen that the equatorial currents are around 600 to 1000 kilometer wide, while the equatorial counter currents are only 500 kilometer wide. Now we will talk about Guiana Current. We have already seen that the South Equatorial Current, it divides at Cape of Sao Rocco, and the northward part of this South Equatorial Current is called Guiana Current. This Guiana Current flows in the northern part of our South America, and we see that a lot of fresh water is discharged from Amazon and Orinoco River. Now the water flows in this direction because we have seen that the trade winds apply a dragging force parallel to the equator, as well as there is rotation of Earth. So both of these forces, they push the water from this mid-Atlantic region towards this Guiana Current as well as towards the Brazilian Current. And there are large amount of fresh water which is discharged from this Amazon River. It changes the salinity in this region. Here you can see that this region has become very less saline because of the fresh water discharge from Amazon River. The blue color indicates less saline region, while the red color indicates highly saline region. So here is the summary. The Guiana Current is a northwest flowing branch of Atlantic South Equatorial Current, which we already discussed, and water is added by Atlantic North Equatorial Current and Amazon and Orinoco. So some part of water from our North Equatorial Current also enters the Guiana Current. River drainage from Amazon and Orinoco reduces the salinity. Now this Guiana Current flows further north, and some water from North Equatorial Current joins it, and we see that it enters the Caribbean Sea, where it is called the Caribbean Current. Here is Colombia, here is Venezuela, and this is Cuba, and this is Mexico. So you can see that it flows north of Venezuela and Colombia and south of Cuba, and it passes through the Yucatan Strait. So it is also sometimes called as Yucatan Current. Here is a summary. It is a warm water current. It flows north. It flows from coast of South America to Gulf of Mexico. It is formed by Guiana Current, and it crosses Uganda Channel between Mexico and Cuba. So it is sometimes called as Uganda Current. Warm waters of Caribbean Current helps in tropical cyclones because the water brought by the Caribbean is from the equatorial region. It is warm water. So when the cyclones are formed, they can get a lot of moisture from these warm waters of Caribbean Sea. So this Caribbean current helps in intensifying the tropical cyclones which are generated in this region. Now this is formed due to water moving from Atlantic into Caribbean Ocean, and we see that it is caused by the force exerted by rotation of Earth as well as the western intensification. And we have already discussed that it flows south of Puerto Rico and Cuba and north of Colombia and Venezuela. Now this Caribbean current, when it enters this Gulf of Mexico, it forms a loop like this. It forms a loop from the Yucatan Strait to this Florida Strait, and that is why this region in the Gulf of Mexico is called a loop current. You can see how it forms a loop over there. So here it is formed by Uganda or Caribbean current. It flows in Gulf of Mexico. It is formed by Caribbean current and it forms a loop in the Gulf of Mexico from Uganda Channel to Florida Strait. Now one part of North Equatorial Current, it flows north of Cuba and south of Bahamas, and it joins this loop current at the Florida Strait. So both of these combine in the Florida Strait, and this is called Antilles Current. This is the summary of this current. This is also part of North Atlantic Geyser, and it runs north of Puerto Rico, Hispaniola and Cuba, but south to the Bahamas. It also helps in fishing because it is nutrient rich stream. Now both of these currents, the loop current and Antilles current, combine to form the Florida current. This Florida current flows from this south of Florida peninsula, from this Florida Strait, and it moves along the coastal regions of the Florida. Here is again the summary. You can read this and take note of all these points. One thing is, it is formed due to piling of water in the Gulf of Mexico from Atlantic. So because water is forced to enter into the Gulf of Mexico, now Gulf of the Mexico is almost closed Gulf, and therefore it gets heated and the water expands. This water which expands in the Gulf of Mexico, it moves out from the Gulf of Mexico via the Strait of Florida, and it moves out with a very high velocity. Now here we can see that the westerlies winds are blowing, and these westerly winds blow from the western direction towards the eastern direction. These westerlies, when they flow over the ocean water, they apply a dragging force. They try to pull the water along with them. Our Florida current also experiences the dragging force applied by the westerlies, and therefore they are pulled along with these westerlies. There is another factor, that is western intensification, which helps in the movement or flow of the current from the eastern margins of continents. In western intensification, we have already seen that because of rotation of Earth and inertia of water, the water is accumulated on the western margin of oceans or eastern side of continents. So because of these two regions, we see that the Florida current flows as Gulf Stream. It flows with a very high velocity and carries a large amount of water. In fact, the amount of water carried by Gulf Stream is second only to Antarctic Circumpolar Current. So this Gulf Stream, because it originates from the Gulf of Mexico, the water comes from the Gulf of Mexico, therefore it is called Gulf Stream. And it passes through the eastern margin of America, and then it goes near the Newfoundland of Canada, that is Nova Scotia region, and then it moves further towards the European region. So here we can see the summary of Gulf Stream. The parent current is Florida current plus Antilles current, and it starts near Florida Strait. It's called Gulf Stream because it originates from the Gulf of Mexico. It is carried east because of the Coriolis force. Of course, the Coriolis force acts on all the currents, and it changes the direction or deflects the direction of the current in the right hand direction in northern hemisphere. So here we have seen that the water current was deflected because of Coriolis force. As well as these westerlies winds, they apply a dragging force on these ocean currents and they carry them along with them. The western intensification aids the Gulf Stream, and that is why the Gulf Stream is able to carry highest amount of water, only second to Antarctic Circumpolar Current. The western intensification causes the currents to carry large amount of water and move with higher velocity, and therefore you will see that the ocean currents on the western margin of continents are weaker compared to the currents on the eastern margin of continents. The Gulf Stream further divides into Canary Current and North Atlantic Drift. Now, the Gulf Stream also has certain effects on the climates of the adjoining region. Gulf Stream along with the North American Drift carries warm water from Gulf of Mexico to Norwegian Sea. So we will see later that the equatorial water which was brought by this Gulf Stream is carried in the polar regions via this North Atlantic Drift. And it provides warmth there, that is, it increases the temperature of England and Western Europe, and we also see that the Norway ports remain ice free throughout the year because of the warm waters brought by the Gulf Stream and then further carried by the North Atlantic Drift. They also increase the temperature of the eastern coast of America. We see that the eastern coast of America will have higher temperatures compared to same cities on the western coast of America. In fact, at Newfoundland, the Gulf Stream meets the cold Labrador Current. And because of this mixing of hot and cold current, we see that there is a rich supply of nutrients as well as there is a suitable temperature. And because of both of these conditions, we see that abundant fishes are formed there. Here we can see that the Labrador Current, which comes from the western side of Greenland, it meets the Gulf Stream near the Nova Scotia or near the Newfoundland. And here we see the structure of the Newfoundland coast. We can see that it looks something like this. Here is the boundary of Newfoundland and this is the coast. Here we see in the coastal region that the reef is not very deep, it is shallow, and therefore the Labrador Current which comes from here is uplifted. It acts something like this. Here, this is the coastal region of the Newfoundland, and when an ocean current comes from this direction, it is uplifted like this. Therefore, there is upwelling. And because there is upwelling, it brings lot of nutrients to the surface of the ocean. And therefore, we see that there is phytoplankton boom. Phytoplankton are food for zooplanktons, and then zooplankton boom occurs. And now because there is abundant supply of zooplanktons, a lot of fish live here because there is abundant supply of food in this region. Here we can see that how this Gulf Stream and Labrador Current meet in this region. Now, why does this Labrador Current has so many nutrients? So why does it bring so many nutrients? So if we see the temperature profile of oceans at the equatorial, we can see that there is drastic difference in temperature at the surface and in the bottom. Because of this, there is very clear stratification of layers based on temperature, and mixing is not possible because hot water or warm water lies at the surface. It is less dense, while the cold water, which is more dense, lies over here. So no vertical mixing is possible. But if we see the temperature profile of cold seas in the polar regions, we will see that it is almost constant. And therefore, vertical mixing of water is possible. And we know that the nutrients are mostly collected at the bottom of the sea because all the marine organisms, they die and decompose on the ocean floor. So because of this mixing in polar seas, we see that there is more supply of nutrients in the surface currents. So we have already discussed this, that the cold ocean waters are rich in nutrients because of vertical mixing. Now, when these cold ocean waters, they meet the warm ocean waters, there is abundant supply of nutrients as well as there is favorable temperature. Therefore, we see a boom in phytoplanktons, which consume these nutrients and the CO2, and there is a boom, there is a phytoplankton bloom. So a large number of phytoplankton start to exist over there. These zooplanktons are small animals which consume this phytoplankton, so their number also increases. Many fishes, they live on these zooplanktons, and therefore we see that there is an increase in fish population in these regions. Now, as we have discussed earlier, the Gulf Stream, when it moves further, it gets divided into Canary Current, which is a cold current, and it moves in the southern direction, while there is another branch of this Gulf Stream which is called North Atlantic Drift or North Atlantic Current, and it moves further north. It moves towards the England and Norway region. Now, if we see in this region, we have polar winds which blow in this direction. but our North Atlantic current is flowing in opposite direction. So what is the force which pulls this North Atlantic current towards the polar region? Now to understand this, we have to understand the role of salinity. So what happens when these ocean currents are moving through this equatorial region or through the temperate region? They experience evaporation. And when evaporation occurs, we know that salinity increases. Here we can see that there is 100 ml water with 5 grams salt. But because of evaporation, we have now 60 ml water with 5 grams salt. So here the proportion of salt is higher. Therefore, this water is saline. So similarly, the ocean currents, when they move through the tropical and temperate region, they experience evaporation and their salinity keeps on increasing. There is another phenomena which occurs in the polar region. When the ice is formed, it is formed from this ocean water. Now we know that the ocean water has a lot of salt. So ice, which is formed from this ocean water, does not retain the salts. It releases them in the adjoining water through a process called brine rejection. Now because this salt is emitted from this ice, the water below this iceberg, it will become more saline. And when it becomes more saline, it will start to sink. And when this water sinks, what happens that a depletion is created at the surface. And because of depletion of water at the surface, water from other regions will flow over here. And therefore we will see a surface current. A very similar process occurs in this polar region. Here we see that there are two regions, one beside the Norway and another in the south of Iceland. These are the two regions where we see that the water sinks because of increase in density of the two factors we just discussed. The first being evaporation of the water when it is flowing through the regions, and second is brine rejection. So because of both of these regions, we see that the water descends in these two regions and there is scarcity of water on the surface over here as well as over here. So this Gulf Stream is dragged over here, which is called North Atlantic Drift. So here is the summary of North Atlantic Drift. It originates near southeast of Newfoundland, where Gulf Stream divides into two. It is largely driven by thermohaline circulation. So basically thermohaline means thermal, that is temperature based, and haline means salinity based. So remember, when this water reaches the higher latitudes, it becomes cold. So its density also decreases. So this also helps in water descending in the deeper parts of our ocean. So evaporation of water increases salinity and density, so the water descends. Again, ice formation increases the salinity by the process of brine rejection, and the current near Iceland becomes dense and cold because of the temperature. Therefore, they again descend. So all these three factors, brine rejection, evaporation, and cold, ambient cold temperature, it helps in the water to sink in the deeper parts of ocean, thus creating a scarcity on the surface. So near the Ireland west coast, the North Atlantic Drift divides into Irminger Current and Norwegian Current. So we see that now it gets divided into two. First is Irminger Current and the another is Norwegian Current. Irminger Current moves towards the Greenland from south of Iceland, and Norwegian Current moves along the coast of Norway. So here we can see the North Atlantic Current dividing into two parts. Now here we can see the North Atlantic Current dividing into two parts. The first part being the Irminger Current, which moves south of Iceland towards the Greenland coast. And we have already discussed that here the water sinks in the deeper part of our oceans. Here is the summary of Irminger Current. It is formed south of Iceland from the North Atlantic Drift. Now the North Atlantic Drift carries saline and warm water from the Gulf Stream. Therefore, the water in both North Atlantic Drift and Irminger Current is warmer than the surrounding ocean waters. Therefore, both of these currents are actually warm currents. The Irminger Current also forms a part of North Atlantic subpolar gyre. Here we will see in later parts of the video that the water will return like this. So it will form a full circle, and therefore this is called subpolar gyre. Now here we also see that the North Atlantic Current is divided into Irminger Current and the second part is Norwegian Current. This Norwegian Current moves further along the coast of Norway, and then it enters the Arctic Sea and it again forms a full circle. So this is also a polar gyre which is formed by this North Atlantic drift current flowing into the polar regions. So here is the summary of Norwegian current which we just discussed. It is formed from North Atlantic drift. It is formed north of Scotland in North Sea. It is colder and less saltier than North Atlantic drift, obviously because it has moved further north, so it loses some of its temperature and therefore it becomes less hot or less warmer compared to North Atlantic drift. Moreover, there is fresh water added from Baltic Sea through the North Sea. Therefore, the salinity of this Norwegian current also decreases. It is also part of subpolar gyre formed of North Atlantic current in south, Norwegian current on eastern margin, and East Greenland current and Labrador current. So we will see this gyre in the next slide. So here we see a Norwegian current, and a part of this Norwegian current, it flows towards Greenland. On the eastern margin of this Greenland coast, we see that it again divides and returns over here. So this is a gyre formed by this Norwegian current. So both of these are actually gyres. And the part of this gyre which moves further along the eastern coast of Greenland is called East Greenland current. This East Greenland current is responsible for bringing icebergs to the Atlantic Ocean. In fact, 90% of the icebergs of the Arctic Ocean are removed from the Arctic region towards the Atlantic by this East Greenland current, and it is actually a cold current. Here we see summary of East Greenland current. It is cold, low salinity current located off the eastern coast of Greenland. It cuts through Nordic seas, that is the seas along Greenland and Norwegian Sea, and it also passes through Labrador Sea. It directly connects the Arctic to the North Atlantic. So we have seen that it brings water from the Arctic Ocean towards the North Atlantic Ocean. And it is the major channel to bring ice and fresh water out of the polar region. 90% of the Arctic Sea is exported out of Arctic through this channel. So we have already discussed that the eastern Greenland channel, it brings lot of icebergs out of the Arctic Sea into the North Atlantic region. In fact, the iceberg which collided with Titanic was also brought by this East Greenland current. And it is of low salinity due to fresh water run from sea ice melting and rivers. So in this region there is a lot of melting of glaciers which adds fresh water in this current, and therefore its salinity decreases, and this is a cold current. Now, this East Greenland current on the southern tip of Greenland takes a U-turn and it moves on the western side of this Greenland, where it is called West Greenland current. Now, this West Greenland current is capable of carrying some small icebergs in the northern direction. Here is the summary of West Greenland current. It's a weak cold water current and it flows north along the shelf and shelf break of the western coast of Greenland, transport small icebergs north, and it is formed by the movement of flowing around the southmost point of Greenland caused by East Greenland current. So basically what we saw, that the East Greenland current which reaches the southern point of Greenland turns back, and a part of it flows along the western margin of Greenland, and that is what we call as West Greenland current. Now the water which was taken north by this West Greenland current, it turns back. The water from Baffin Bay and the Hudson Strait are added, and that water flows as Labrador current along the margin of Canadian coast, and it meets the Gulf Stream near the Newfoundland, which we have already discussed that here they are good grounds of fishing are produced because of mixture of this cold current with the warm current. But the Labrador current does not stop here. It further moves south and it provides cold weather to the northeastern states of USA. So you can see that it reaches as far as over here. So here is the summary of Labrador current. It's a cold current and is formed by very cold water from the Arctic region, which has temperature of 1.5 degrees Celsius. Water is added from Baffin Bay and Hudson Strait. It flows from the Arctic Ocean south along the coast of Labrador. Labrador is a province in Canada, and it passes around the Newfoundland of Nova Scotia, and here it meets the Gulf Stream. It produces heavy fogs in this region where it meets the Gulf Stream, and it is one of the richest fishing grounds in the world. We have already discussed that why it is one of the richest grounds for fishing. Labrador Current transports icebergs from the glaciers of Greenland southwards, and it has a cooling effect on Canadian Atlantic provinces as well as the northeastern states of USA. So we can see that the temperature on the northeastern states of Canada is reduced because of this Labrador Current. So we have already discussed that the Gulf Stream gets divided into two parts. We discussed in detail what happens to the North Atlantic Drift. Now we will discuss about Canary Current, the southward part of this Gulf Stream. Now because this Canary Current is carrying water which is cooler than the ambient water in the oceans. Therefore, this Canary Current is called as cold ocean current. Now it flows on the western margin of our northern Africa. Here you can see some islands. These islands are basically called Canary Islands, and it is on the name of these Canary Islands we call it as Canary Current. Now here an important phenomena occurs. Because of the trade winds which are blowing parallel to the coast, we see that Coriolis force acts in this direction, and therefore the Ekman transport moves the water away from the coast, and therefore there is a depletion of water at the surface, and therefore water rises from below and it creates a major upwelling region here. So on the Canary coast there is a major upwelling region. It is one of the 5 upwelling regions in the world, and we have a separate video explaining all these 5 upwelling regions. If you want, you can check out that video. The link should be available in the description. Here is the summary of Canary Current. It's a cold current because the water this Canary Current carries is cooler than the water in the surrounding ocean. Therefore, it is called a cold water. This Canary Current is wind driven because the winds, the trade winds which are blowing parallel to the western coast of North America, they carry the water of the Canary Current along with them, and therefore it's a wind driven surface current. It is named after Canary Islands, and it branches from North Atlantic Drift and flows till Senegal, where it joins the North Equatorial Current. Upwelling occurs along the western margin of Africa. We have already seen that there is a major upwelling zone, and which occurs because the winds are blowing parallel to the coast, and there is an Ekman transport of water occurs on the surface. On the surface the water is depleted, therefore water rises from the bottom. So it is a major upwelling region, and nutrients are brought from the deeper parts of the ocean to the surface. So it is also a major fishing zone. Now here we can see that the Canary Current moves further south. Near Senegal it meets the North Equatorial Current, which we already discussed. But a part of this Canary Current, it flows parallel to the coast of Africa, and it meets the Counter Equatorial Current. So this is again a warm current because it is flowing in the equatorial waters, and it carries warm water. Here is the summary of Guiana current. It's a slow warm current, so it does not flow with very high velocity, and it flows along the coast of African Guiana, and it meets the African equatorial counter current. There is another ocean current which originates south of the Newfoundland from the Gulf Stream. It is called Azores Current, and it is also a part of this gyre. That is the North Atlantic gyre. This Azores Current also, it separates from this Gulf Stream and it meets the North Atlantic Current over here. Now we will see the ocean currents in South Atlantic Ocean. We have already seen that the South Equatorial Current divides into two parts. The first part we have already discussed, which moves in the northern direction. Now we will discuss the Brazilian Current. So this Brazilian Current moves along the coast of South America. Here we see that there is a delta of several big rivers of South America, which includes Parana River, Uruguay, Paraguay rivers, and other rivers. So this is a very large delta. The Brazilian Current moves along the coast of Brazil till this Rio de Plata, and then it moves away. The reason why it moves away is the westerlies blowing in this direction. The westerlies move from here towards here, and therefore they drag this Brazilian Current along with them. This is the summary of Brazilian Current. It's a warm water current, flows south along the Brazilian coast to the mouth of Rio de Plata. So this is the delta of the several rivers which we discussed. It is also a part of South Atlantic subtropical gyre. It is a western boundary current. Just like the Gulf Stream, this is also a western boundary current, which means it flows on the western side of the ocean. And it is the southern counterpart, but it is considerably less shallower and weaker. So compared to the Gulf Stream, this is considerably slower and weaker. The reason is that the Gulf Stream has higher supply of water because it gets water from both North Equatorial Current and South Equatorial Current. Remember, part of South Equatorial Current divides and moves in the northern direction. Secondly, the water which is heated in the Gulf of Mexico, it moves with a very high velocity out of the narrow Florida Strait. And that is why the Gulf Stream has higher velocity compared to all other currents in the world. This Brazilian current joins the Falkland currents at the Argentinian Sea. And the saltier subtropical water of Brazilian current meets the fresh water of the Falkland Island. Again, there is this cold current meeting with the warm current, and therefore we see that there is good supply of nutrients in this region as well as there is favorable temperature. And because of both of these, there is a boom of phytoplanktons which are eaten by zooplanktons, which are again eaten by fishes. So we see that there are good conditions for fishing in this Falkland region where both of these Brazilian current and Falkland current meet. Here we can see a part of Antarctic circumpolar current. It moves north and then it joins the Brazilian current. So this is the region where we have very good conditions for fishing. Here is a summary of Falkland current. It's a cold water current because it originates from the Antarctic circumpolar current. And it carries fresh water because it comes from the polar regions. It flows northward along the Atlantic coast of Patagonia, which is in Argentina, and it moves till Rio de Plata. So we see that both the Brazilian current and the Falkland current, they move towards this Rio de Plata and then they separate away from the coast. It transports nutrient-rich cold waters from the Antarctic circumpolar current northward. So we see that the Antarctic circumpolar current carries a lot of nutrients, and this Falkland currents, it takes these nutrients northward towards the Brazilian current. And where it mixes with the Brazilian current, it provides very good conditions for fisheries. The current results from the movement of water from the west wind drift as it rounds the Cape of Horn. So we see that the Falkland current divides from the circumpolar current because of the edges which are created by this Cape Horn. Here is Cape Horn, and because of the effect of this Cape Horn, we see that a branch of this circumpolar current, it moves northward. Now we see that both of these streams, that is the Brazilian current and the Falkland current, they combine together and move as South Atlantic current. Now remember, this South Atlantic current is separate than the circumpolar current. They move together, but still they are separate. Now this South Atlantic current is again a cold water current, and it moves eastward under the influence of our westerlies. The fraction of it reaches African coast feeds the Benguela current. So because this Atlantic current which reaches the African coast, it forms a Benguela current, which we will see in next slide. It is the southern branch of subtropical gyre in South Atlantic, and it is distinct, as we have discussed, it is distinct from Antarctic circumpolar current, and it moves under the influence of strong northwesterly winds. Now this South Atlantic current and the circumpolar current, they combine. Some water from the circumpolar current as well as water from the South Atlantic current moves north, and they combine to form this Benguela current. This Benguela current, under the influence of trade winds, moves further north and joins this South Equatorial current. Again, the process of upwelling occurs over here. As we have seen in the Canary region, we also see upwelling over here because the winds are blowing parallel to the coastal region. So here is the summary of Benguela current. It's a cold water current. Remember, the water comes from the South Atlantic current and the circumpolar current. Therefore, it's a cold water current, and it is driven by the easterly trade winds. We have seen that in the northern parts of this Benguela current, it comes under the influence of trade winds. Southeasterly winds drive coastal upwelling, forming the Benguela upwelling system. So we have seen that there is an upwelling region over here which brings nutrients from below, and thus there is a phytoplankton growth over here. There is also a region where the Benguela current and the Agulhas current of our Indian Ocean comes very close to each other. However, they do not meet, but water from the Indian Ocean passes to the Benguela current via the edges which are produced at this place. So the water in the Benguela current comes from three distinct regions. The first is cold upwell water from the depths of Atlantic Ocean. Then South Atlantic Gyre, that is the South Atlantic Drift and the Circumpolar Current. And then the edges which form on the southern side of Africa from the Agulhas Current, they also add water to the Benguela Current. Coastal areas adjacent to the current experience a desert-like situation. So basically, because it is a cold current, the winds which blow over these cold currents, they lose their moisture in the form of fog. And when they reach the land area, there is no moisture in those winds. And therefore, these areas fill a arid-like situation. And therefore, we see that the Kalahari Desert, which is located in South Africa, is formed because of the effect of this Benguela current. I hope I was able to explain the ocean currents in the Atlantic region. We have separate videos for ocean currents in Indian Ocean and Pacific Ocean. Do watch those videos, and if you like those videos, then please subscribe and press the bell icon. If you have any doubts, then you can ask them in the comments and we will try our best to answer them. If you like what we are doing, then you can contribute to our cause by using the QR code. Thank you. Thanks a lot for watching the video.